Hey, what is up everyone? Welcome back to another video. In this video, we're going to learn all about exploiting MFA or multi-factor authentication. Now, unless you've been literally living under a rock, you know what MFA is. You likely have to do it at your own job. MFA is that thing when you log into an application, you get that annoying code or a push to your phone, and you have to then approve it. You have that second factor of authentication. But here's the thing, MFA is amazing. A lot of organizations and governments are enforcing MFA because it's a really good defense in depth technique to stop threat actors and attackers from taking over your account, but not all implementations of MFA are made equal. So in today's video, I want us to do a deep dive into MFA, specifically like what it is, the theory behind MFA, but then we're going to get hands-on with exploiting 3 different misconfigured instances of MFA that you might just discover in the real world through a bug bounty program or through a pen test. But let's begin at the beginning. What exactly is MFA? Well, MFA, as it sounds, is multi-factor authentication. It means you require more than one factor to authenticate to an application, and generally there's 3 different factors that might come to mind. I'll throw this graphic up for you, but the first is something you have, right? This might be like your phone that's on you. So when you log into an application, you get a push to your phone, and you have to have that phone on your person to authenticate to the application. The other thing might be something you know. This is generally what we think about. You type in your username and then you type in a password. Well, that password is something you know. That's one factor of authentication. And another factor might be something you are. This is the biometrics, the eye, the fingerprint, the eye scanning. Like I think about like the sci-fi movies when it scans your iris. But when you do that, that is biometric authentication, and that is one factor of authentication. Now, what we are going to do in this video is we're going to get hands-on with all of this through a new lab by TryHackMe. Now, I do want to be clear, this lab is only available to subscribers, but I am not paid by TryHackMe. Matter of fact, I pay TryHackMe to be a subscriber. So TryHackMe, if you want to give me a free subscription for always promoting your stuff, hey, go ahead and email me and give me my free sub. But I do have a sub to TryHackMe. They are well worth the time, well worth the money, and they recently released a lab all about bypassing multi-factor authentication. So here is the lab, and I would encourage you to do 2 things as we get the lab open. First, just go to the lab. Multi-factor authentications, log into your TryHackMe account. You should be able to find the lab, but you need to go ahead and start the attack box if you haven't already. You can see I've already started the attack box, as well as start the machine. It will just take a little bit to boot up, and this is what we're going to be using for our hands-on lab later on in this video. But the first thing that we need to do is we need to add this IP. Yours is going to be different. It's the target IP to our Etsy host file with MFA.thm. Now, if you're new to Etsy host and all this kind of technical language, Etsy host just resolves names to an IP address. You can kind of think about it like on your phone. I think Network Chuck made a really good video about DNS and how it works this way. But on your phone, you have a contact. It might be mom, dad, whatever it is, and it connects to a phone number. Your phone is kind of like the Etsy host. It connects a name to a phone number. Well, on a Linux machine, Etsy host connects a name to an IP address, and in order to make this lab work, we need to make an Etsy host file right here, not a file. We need to add to our Etsy host file with this IP with MFA.thm. The way we can do that is we'll go ahead and grab our target IP address, and then we're going to switch over to our attack machine right here, and we will go ahead and open up the terminal. And I wonder if I can make this a little bit bigger. We'll go like this. I think the hotkey will break because it's a web browser, but this should be good enough. There we go. So I'm going to do sudo nano Etsy host. Nano is just a text editor. So if you're used to Windows, think about like notepad.exe, very similar thing, just a text editor. And let's go ahead and drop in our IP address there, and we'll do mfa.thm. And once you have that typed in, I know this looks a little bit confusing down here, but to exit, that caret key just means control on your keyboard. So if you want to exit, I'm going to hit control on my keyboard and then the X key. And then it's going to say, hey, do you want to save this file? And yes, of course you want to save the file. So I'm going to click Y on my keyboard. And then finally, file name to write. We don't want to change the file name, so we'll just keep it at Etsy host, and we will click enter on our keyboard. And just to verify this work, we can try to ping MFA-THM, and our ping goes through successfully. So when it comes to MFA and 2FA, it's a little bit confusing. Like 2FA is a form of MFA, but technically MFA can have 3FA. It can have different factors, if that makes sense. In the lab that we're working on today, we're going to specifically exploit 2FA, or two factors of authentication, which is commonly what you see in the real world when it's a web app, or maybe it's AD, or even getting access into a building is often two different factors of authentication. And let me just give you a few examples, things that you might recognize. One is called a time-based one-time password, or a TOTP, time-based one-time password. These are temporary passwords that change about every 30 seconds. You may have used this before. A few common platforms are things like Google Authenticator and Microsoft Authenticator. You have that 6-digit code and it's going to change every 30 seconds. Another common thing is push notifications. This is Duo or Google Prompt, that instead of a code being sent to your phone, you'll log into the application, your phone will buzz and it will say, hey, do you approve this login thing, right? And you'll say, yes, I approve the login. You'll click yes on your phone and it allows you to authenticate to the application. Another one is SMS, which is almost the most often used one, even though it's technically less secure, rather, but SMS sends a code via text message. Now, the reason that's less secure is text messages can technically be intercepted in various ways, so an attacker could then intercept that text message and get access to your code. And then finally, we have hardware tokens. These are less commonly seen, but more often used in high security environments like government or security roles, but this would be like a YubiKey. It works offline, doesn't require an internet connection, and it's literally a hardware token that you carry with you to be that second factor of authentication. But on top of this, what is often implemented is what's called conditional access. This is especially true in the cloud. You think about Azure, AWS, you'll often stumble across conditional access. And there's a few different things here that we need to understand. One is location-based conditional access. That means if you try to log into your account from Russia or a country you don't normally log into, it's not going to allow you to log in because it only allows IPs from, let's say, the US to log in. Now, this can, of course, be easily defeated by VPNs, but remember, defense in depth is key. The more defenses, the more layers you have in place, the more difficult it makes it for an attacker. Another thing is a time-based conditional access. If you usually log into your account between the hours of 8 a.m. and 5 p.m. Central Standard Time, and all of a sudden someone logs into your account at 2 in the morning, well, that might be a red flag, and maybe you won't be allowed to log in, or there'll be additional security measures to allow you to log into your account, because that's anomalous behavior that's out of the ordinary. You don't normally log in at that time. Another one that's a little more difficult is behavior analysis. A lot of CAPTCHAs actually do this, that they try to analyze whether or not the person on the other side is a bot or a real person. So they look at behavior of the user to see, hey, is this a normal user's behavior? Is this an attacker? And they try to stop it via conditions. And then finally, we have device-specific conditions. So if you work a job in IT, what often happens, or even not in IT, you might get a phone, or if it's a bring your own phone situation, you'll have a work profile on your phone, or you are given a phone from your work, and only that phone allows to authenticate to your work apps. If you try to authenticate to the work apps from a non-compliant phone, it just won't let you get in. That conditional access policy is going to stop you, and it requires a compliant device. So those are different forms of conditional access, but let's get hands-on with actually exploiting MFA. There's a few different things that we're going to exploit. The first one is what's known as OTP leakage, or one-time password leakage. This is often due to bad coding practices or debug being left on. And I know this sounds a little bit unbelievable, but I've actually seen this in the real world. When a developer or anyone is pushing things, they try to make it easier to work, right? But the easier you make it to debug or to troubleshoot, well, the more opportunities there are for an attacker. So once again, I've literally seen this in the real world on a web app pen test, on a production application, this exact issue that we're going to look at, where it actually leaks the one-time password in the application response. So let's go ahead and look at this together. I'm going to go ahead and share my screen. We're back on the attack box, and let's open up our web browser. Once our web browser is open, we're going to navigate to this first lab, and this first lab is right here. We're going to type in HTTP. We'll see if I type it right, mfa.thm labs first. And there you go. Tyler does not know how to type. Good job, Tyler. Let's go ahead and do that. There we go. And I believe our account, I should probably just check. I think it's like mail@THM, but let's go ahead and see what account we are supposed to be using. We'll jump down to this lab, and here our credential should be THM@mail.THM and test123. So easy enough. We'll do THM@mail.THM and test123. And what we want to do while we do this is we're going to open up our developer tools and let's monitor what's going on in the background on the network level of things and see what requests are being made. We can do that by opening the application menu here, clicking more tools, and then finally we will go ahead and navigate to web developer tools, and we can go to the network. Now this is just going to show us all the requests that are flying through the network. I don't know if I can zoom in on this at all for you guys. There we go. I can. Beautiful. And let's go ahead and log into the application. When we log into the application, we see a few things going on here, but we have this post request here to labs first. And if we click that, we can see, I'll try to make this even bigger for you guys. If I scroll up here, we can see the headers being sent. We can see the cookies being sent. We can see the request, and we can see the response here. But if we look through here, we have another GET request to the MFA endpoint. And we have an interesting post request here to token. And if we look at our post request to token, we are given the token actually in clear text right here. The application is responding with this so that if the user types in the right token, it can verify this is the correct token. But of course, it shouldn't be showing us what the token is. Now, seems unrealistic, but once again, when developers leave debug on or don't understand secure coding practices, they just want it to work, you might discover an issue like this, and it's returning the one-time password to us. I've also seen it in the real world. We'll go ahead and type this in. Oh, good job. Apparently copy and paste doesn't work. I've seen in the real world with password resets as well. I had one time on a web app when I was testing the password reset functionality, and when I proxied the request with Burp or Kaido, I would send it to repeater, I would send the request forward, and although it didn't show you in the GUI, in the response, it literally gave me the reset code that it sent to the email. So I could take over anyone's account without access to the email because the application was literally giving me the reset token. So these are real issues that you might stumble across in the real world. I am going to have to refresh this page. We'll see if it goes through. And there's our token right there. It responds again. We'll go to the response, and this is 2781 now. So we'll type that in, 2781, and we will click verify account. And there we go. We have bypassed MFA or 2FA via OTP or one-time passcode leakage due to insecure coding or debug being enabled in production. Now, the next thing we're going to do is we're going to try to bypass insecure coding or a logic flaw. You see, what can happen when it comes to 2FA is the developer may have it set up so it requires 2FA when you log in, but you can literally just leave the 2FA screen and you already have a valid session on the web application, and you can still hit the dashboard and anything else that you want. So let's go ahead and do this in action. We'll go up to our URL here, and let's go to the second lab. We'll just go to labs second, like so. And same thing, I think it was was it THM or was it mail@THM? I don't even remember. I can't even remember the login. Come on, Tyler. THM@mail.THM. All right. THM@mail.THM and test123. We will go ahead and log in. And it says, hey, we require email verification. Please enter the 4-digit verification code that was sent to your email. But here's the thing. Sometimes when MFA is implemented, they have a logic flaw here that as soon as I authenticate, it gives me a valid session. And although it looks like we need MFA, well, we have a business logic flaw where we can just go directly to the dashboard, and we have just bypassed MFA due to bad coding logic and bad coding in general, right? It was giving us a session when it wasn't supposed to give us a session. We bypassed the two-factor authentication, and we were able to get the flag. Now we have one more lab on here that I think is the most interesting, but probably the most complex to understand. So we'll try to go through it slowly. But this third lab is going to be a common MFA practice. I'll even just show it to you. Let's jump over to our third lab. And if Tyler could type right, again, there we go. Here's our third lab. So we'll do THM@mail.THM and test123, and we will go ahead and log in. And now we want to give it our 4-digit code. So we'll just do 1234 and verify account. And you'll see it logs us out. It actually de-authenticates us. And so that makes it a lot more difficult for us. We can't bypass it. We can try some of the things we already tried. So if we do THM at mail.thm and test 1, 2, 3. We can go ahead and monitor the network and see if anything is coming through on here. Maybe not settings. If I knew how to use a computer, that'd be a good starting point. More tools and web developer tools here. Right, so we have our network pulled up. We can go ahead and log into our network. And we see some things coming through here. We have the GET request to MFA, but we have nothing interesting in the response besides a 4-code verification to enter in. We can try to enter in our 4-code verification, see if we get anything there, but it's just gonna log us out and we're gonna bypass back to our login screen. So we need to do a reverse brute force attack. We need to have a Python script that attempts to log us in, that automates this process, but it's a reverse brute force. Instead of us trying every possible digit, we're just going to choose one 4-digit combination, and as long as you go through the attack enough times, eventually the one-time code is going to match that combination. Right? Does that make sense? Instead of doing like 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, or that would be 1, 2, 3, 5, 1, 2, 3, 6, we're just going to choose something like 1337 and keep trying to authenticate until the one-time code is 1337, and then we're going to be able to access the application. Now, creating the script is kind of outside the scope of this lab. I'm going to show you the script that TryHackMe actually gives you, but I'll tell you one fun challenge. I did this myself when I was going through it. Try to make your own script. Look at the logic, and rather than using TryHackMe's script, try to code it yourself. That'd be a fun challenge that you can take away from this lab, some homework that you can do with you, ChatGPT, Copilot, whatever you want to do. See if you can make your own script that does this. But for the purpose of this video, we are going to showcase the official TryHackMe script that you can get directly from the room. I'm going to copy it from my notes here, and we'll walk through this script. So we can open up like Sublime Text here. That might be the easiest way to see it. And no, we don't want to upgrade it. And I'm going to paste in this script here. Does it not give me any type of code highlighting? Oh, maybe I should save it. Let me go ahead and save as, and we'll just call this MFA.py. There we go. Now we have some syntax highlighting. So if you're new to Python, let me walk through the script for you. I'll zoom in so you can see it, make sure my face isn't blocking the script. And we're going to go through this slowly so you understand what the script is going on, so we're not just script kiddies firing off a script. The first thing that we're doing is importing the request library. Now, in Python, you can import various libraries, and one of the libraries is the request library that allows us to make HTTP requests, which is exactly what we want to do. So teaching full Python libraries is outside the scope of this video, but there's a lot of great tutorials on using Python and importing libraries. But that's what that import statement is doing there. Now they've added helpful comments here, so we're defining URLs for login, the 2FA process, and the dashboard. So our login URL is where we're just at. This is how we log into the application. So if we go back over to here, and what I like to do is actually preferences. I like to pin the doclet on here. So you can do this yourself as well. If we just turn off hide doc, then we don't have to fight with that. But if we go back to our browser, here it is, labs third, and that's what that is talking about there. Our OTP URL, when we log in, it redirects us to the MFA, so that's going to be the 4-digit code it's looking for. And then finally, if we authenticate successfully, it's going to send us over to the dashboard. That's what we've seen every single time. So we're going to try to authenticate, we're going to try an MFA code, and then hopefully it's going to send us over to the dashboard, and that is what is going on here. Now we wanted to find our login credentials, right? We know valid credentials. Maybe we got this from a breach or a phishing attack. We have valid credentials, but we're stopped in our tracks because of the MFA that is enabled. So we're going to put in our valid credentials here. We have THM at mail.thm and our password of test123. And now we're just defining headers to mimic a real browser. Not super important that you do this, but if you want to evade detection by a WAF or the blue team, you want to make the request look as realistic as possible. And one way of doing that is including common headers, right? If our user agent said, for example, brute force, well, that might be a sign that it is being brute force. So we're just defining our headers here. We're setting up our variable here. So when we send it the HTTP request, it's going to include these headers in the request. Now we have a function to check if the response contains the login page, right? So are we able to actually authenticate? Right? That's the question it's doing there. Is it a 200 response? We have a function to handle the login process. So we're sending our credentials and the headers in order to log in. And now we have the 2FA process. And we're splitting the code into this code 1, code 2, code 3, and code 4, because that's actually how the application is doing it. And I can show you that in practice. If we open up Burp Suite Community Edition, Hopefully it doesn't take too long to open. I believe in you, Burp Suite, although Kaido is better. Just giving a shout out. I normally use Kaido. Kaido is a web app proxy tool written from the ground up in Rust, but doesn't have the silly rate limiting that Burp Suite Community Edition has. But we'll go ahead and open up Burp because it's built into the attack box. Come on, Burp Suite. Starting project. Please wait. We are waiting. We are looking at the blue bar, or the orange bar. I'm colorblind. I'm not really colorblind. I just apparently don't know my colors. I need to go back to school. But here we go. We have our proxy open up. Let's go over to Firefox and we can sign into the account. Let's turn on our proxy and we can look at each one of these requests. So we'll do thm at mail.thm and test123 and we will log in. Now when we do that, it's going to send over to Burp, and I apologize, this is kind of small text, but I have a difficult time making Burp bigger, at least in the attack machine. It doesn't let me do anything, but you can see it's passing our email here, URL encoding the @ and our password of test123, and we will forward that request. We're getting our GET request to MFA, we'll forward that request, and then we're on the MFA page. Now if we type in 1, 2, 3, 4 and verify our account, we go over to here, and this is why it's breaking the MFA code up, because the application does that. In the post request to Labs third MFA, we have code 1, code 2, code 3, and code 4. So that is why the script is doing that. We can turn off the proxy and jump back over to here. Just wanted to explain why that looks a little bit strange there. We're splitting it into individual parts. Finally, we have a response. We're just disabling auto redirects from the response, and it's going to tell us, hey, here's our OTP submission response status code, whether or not it was successful so far. Function to check if the response contains the login page, right? So we want to know, hey, is it just redirecting us to the login page, or are we actually going to successfully authenticate? We have our one-time string. I don't know why I put hack smarter in there. That's not going to work. We're going to do our hard-coded OTP. We'll just say 1337. Now remember, this threw me off quite a bit actually when I was doing this room. This is a reverse brute force attack. Normally when you're doing brute force and you're trying every possible string, well here we know that eventually the one-time code is going to be 1337 or some other 4-digit code. So we're just going to try it over and over and over and over and over and over again with this one-time code and hope 1337 works. If it does try to log in, we're going to try to log in successfully. We're going to try our 1337 code. And then it's basically going to tell us whether or not it was successful. And if it's successful, it's going to give us the cookies, right? If it successfully bypassed 2FA and landed on the dashboard, we can see this very easily. It's the logic. If the location header equals lab's third dashboard, because we know if the location header equals that, we've successfully logged in, then print to the console, successfully bypass 2FA with OTP, and that's going to be 1337. But here's the key. It's going to return the session cookies. So then when we have a session cookie, we can set that as our session cookie and hopefully authenticate to the application and bypass the 2FA and the brute force protection that is on this machine. So with that as our code, let's go ahead and Control S to save it, which I think works here. We'll also save it that way, and we will open up our terminal. Now, if I ls, we have the mfa.py. We'll clear it out, and I'm going to do Python 3 mfa.py, run it. Always cross my fingers because there's always a good chance I maybe did something wrong, and we'll let it keep going through. See, it's just going to keep trying 1337, 1337, 1337, and we successfully bypassed it. Just 1337 over and over again, that reverse brute force attack. It eventually worked, and it gave us our session cookies. Now, we're not done quite yet. We want to take our session cookies, go back over to Firefox. Over here, we'll go to More Tools again. Back to our web developer tools we should be a little bit familiar with, but now we're going to edit our cookies. So if we go over to storage here, we can see we have a PHP session ID here. Well, we want to use a PHP session ID that we just got that is going to work to bypass MFA. And with that, we can type in dashboard. And we have successfully bypassed the MFA, doing a reverse brute force attack, and we are given our flag. So what are some of the takeaways? Well, first, if you're not using 2FA or MFA, you should be. Truly, if you're only relying on a username and a password for authentication, you are asking to get yourself pwned by a hacker or a threat actor. But the second thing is when you do implement MFA or 2FA in your organization, make sure you do it securely. One of the things you should have noticed in this lab is all of these used 4-digit codes. Good MFA uses at least a 6-digit code or larger, and it has brute force protection in place or rate limiting in place. If this endpoint had rate limiting in place that locked our account after a certain amount of failed OTP attempts, or just stopped us from doing our reverse brute force attack, that also would have stopped us in our tracks. So secure coding is important when it comes to enforcing MFA. And from my own experience, you probably shouldn't throw together your own authentication or your own MFA policy. There's a lot of good third parties that do this for you that you can implement into your application to make this more secure, to stop a hacker or a threat actor from bypassing your MFA and pwning your account or pwning your organization. So hey, hopefully you found this video helpful. If you haven't done the lab yourself, check out the lab. I'll drop a link in the description of this video where it provides a little more fuller detail of everything that we've done. Hey, hope you learned something in this video, and I will catch you in the next one.